This is TCI Matter at puzzle page 57, Molecular Motion in Gases. Someone has accidentally burned some food on the stove. The smoke that results spreads out as it moves away from its source and slowly fills the kitchen. You better open a window. How can smoke let you see the properties of a gas? Smoke is actually made up of tiny bits of solid matter that are carried by the air, a mixture of gases. Gas is the state of matter in which its atoms or molecules are separate from each other by empty space and can move independently. As a result, a gas's shape is even more changeable than a liquid's. Just as the macroscopic properties of solids and liquids reflect the individual arrangement and motion of their molecules, so do the properties of gases. Like solids and liquids, the particles of gases are always moving. However, the molecules in a gas, such as water vapor, are not crowded together in a tightly packed arrangement. Instead, they are spread apart, as shown in figure 3. They do not even touch, except when they run into each other. This is figure 3. It says molecules that make up a gas have plenty of space between them and move independently from one another. This freedom of molecular motion causes a gas to have a changing shape and volume. Though water vapor is not visible, you can see how a gas can change shape and volume when you look at steam, which contains droplets of water as the vapor condenses. How do gas particles move independently? You can model a particle's motion by treating it like a racquetball that's been hit by a player's racket. It travels in a nearly straight line until it collides with an object, such as another molecule or a wall of its container. Then it bounces off in a new direction. The molecules of a gas move this way in random directions until they happen to fill the entire container. For the molecules of air that carry smoke particles, the container happens to be your kitchen. Because of the behavior of the particles, a macroscopic amount of gas takes the shape and volume of its container. Suppose you had a bottle full of air. What would happen if you crumpled the bottle into a smaller volume? The gas molecules would continue moving independently, as they always do, only they would be squeezed a little bit closer together. In this way, the shape and volume of a gas depends on the shape and volume of its container.